Okay, it is 1:05 p.m. and it's time to get started. So we've got another fantastic technical session here for you all today. Thanks for joining us. We've got Julien Le Dem from Datakin. He's going to give us a really interesting talk on data lineage. So without further ado, over to you, Julien.
Hi, everyone. So this is Julien. I'm the CTO and co-founder of Datakin. You may have heard me speak about Parquet or Arrow in the past, and today I'm going to talk about Marquez, which is a project now part of the LFAI Foundation to collect lineage and metadata and understand what is going on with your data pipelines. So today in the talk, I'll talk about the problem we're solving. Why do you need metadata and what metadata? And then I'll go over what Marquez is, why we built it, and then details on how it works, in particular taking the example of Airflow, and I'll chat a little bit about the Marquez community. So first, why metadata? So the main goal, I think nowadays you hear people talking about data ops, talking about data mesh, and there's a movement really to be more agile, to have each team in a company to own their own analytics, to own their job, to own their machine learning. And really you build an ecosystem of teams depending on each other and people consuming data, producing dashboards, and depending on each other. And as this ecosystem grows and grows, you have more interdependencies, and then you start having issues due to the complexity of all those dependencies. And every time someone changes something, they break something. And so as those ecosystems grow, you kind of lose the agility you had by having people, instead of centralized teams that do certain things, or you lose this agility of people owning their own area, right? Because every time something changes something, they break something, and so they tend to not change anything. Like this ecosystem tend to ossify and then not change anymore. And so we're going to talk about what we can do to improve that, right? So you have those interdependent teams, and they understand very well their area, but they don't understand that well how other teams work or how change are happening. Our teams may not be aware of who depending, who is impacted by the change they're making. And so there's a lot of friction that happens at the team boundaries, and creates breakage, and then data pipelines break, and then it takes a long time to figure out what's going on when you lack context. So some of the limited context and question you want to ask is, what is the data source? Where is this data living? What is the schema? How is it evolving over time? Who's the owner? Who's responsible for that thing? Who's making sure that this data set is updated? How often is it updated? Where is it coming from? Who is using that data? What has changed, right? Who is going to be impacted by a change? How do I understand if I'm going to impact someone when I do a change that I think is necessary? And so I've stolen this. You have this Maslow's hierarchy of need, which is a common theme that is reused in presentation. It's talking about before you want to achieve happiness, right? You have underlying goals that are important. First, you need to be able to eat, to sleep, to have somewhere, a shelter to stay. And once you have those basic things, then you can look into how do I live better, how do I improve, and all those things. And so there's similar things for data, right? When you look at your data, the first thing, it needs to be available, right? You have to put your data in a place or have access to it so that you can start doing analysis, or you can start extracting insight of build feature around it. And second, it's like the data needs to be updated in a timely fashion. It needs to be available, but then whenever it changes and whenever there's new data, you want to have it in a timely fashion. So there's like freshness. And third is data quality. You want to make sure the data you're getting in a timely fashion is actually accurate, right? There's no problem in the instrumentation or in the transformation or some misunderstanding that makes your data bad quality and give you wrong results to what you're expecting to achieve. And that's kind of the baseline, that's a water line. Like once you have your head above water, that's when you can start getting to the next step of how do I optimize my business, right? Like as an example, you can say, how do I make our systems better? How do we make things cheaper? How do we make things more efficient? Extracting insight for your data. And then once you have this, that's where you can start thinking about, oh, how do we have new business opportunities? How do we get further than making what we already have better? So it's kind of this hierarchy of needs, but the bottom line of this is before you get value out of your data, you need to get your head above water, right? You need to get out of frequent breaking changes in your data, and maybe suddenly a dashboard is not being updated anymore, and maybe someone changed a schema somewhere, or some database is not being refreshed anymore, or something else, right? And you want to get visibility and fix all those things. And once this is a well-oiled machine and it's working, then you can look into how do we improve, how do we make things better, how do we get value out of these things. But often those bottom layers are the ones that kind of hinder the ability to extract value from your data. And so that's where, ta-da, I'm going to do the intro of Marquez. Marquez is an open source project. We started at WeWork as part of building the data platform here, there. And it's an open source project to collect all the metadata about all the lineage, about all the jobs and all the runs in your data ecosystem. Like everything that when it's running, what was the version of the code, what was the version of the input, what was the version of the output, when it started, when it ended, what were the parameters, and how they all depend on each other, and build this entire lineage graph of all the interdependencies within your organization. And so it sits somewhat at the boundary between data operation, data governance, data discovery, right? There's this aspect of understanding everything that exists, understanding where the data is going and where it should not be going, and these data operations of understanding if things are running, if they're running in a timely fashion, if they're taking time, if they break often, and what has changed. And so this project is grounded, so to speak. So a lot of the concept in there are borrowed from the ground paper from the UC Berkeley, which is, like if you look at the beginning of the paper, there's this notion of, it's not just big data, it's big metadata. It's not just about whether the data set is big, that's a problem. It's that you have many data sets and many transformation and many people interacting with it. And that becomes very complex. And you have to deal with this complexity. And as an example, so this is kind of an example of what data platform, if you have one, or like what it could be looking like. It starts from ingesting the data, and then you store it somewhere, and you have a ingestion would work typically in two ways, right? Either you replicate some operational database to get some state, or you send events through something like Kafka and collect events about what's happening. And then typically you have some kind of archival of the streaming data in a at-rest storage, and you can use streaming framework like Flink or Kafka Stream or Storm or other things to process that data in real time. Or you can, and you also usually use a scheduler to have batch processing, like some kind of hourly, daily jobs that will process this incoming data and build dashboard, do machine learning, transform the data, curate the data, and make it usable. And typically, you have also a BI stack that may or may not be the end value of this data, and a bunch of dashboards may be using Power BI or Tableau or Superset or other things to analyze your data. And the point here is like end to end, you want to understand how the data goes through, how it percolates through this whole environment, and if it's happening in a timely fashion, right? So all those things, from the ingestion to the BI to the machine learning jobs and the models being produced, you want to instrument to collect metadata and understand how all this is happening, and having visibility, being able to observe what's happening and when it changes especially. And so, the Marquez model boils down to a generalization of a few concepts, right? You have the concept of job and you have a concept of data set. And the lineage graph is a bar graph of always jobs consuming data sets and producing data sets. So you build this bar graph, but then what we are very careful about, it's not just about jobs and data sets, it's also about understanding every run and really building that lineage graph at the run level. So any run can, you know, when it started, when it ended, what was the version of the input it consumed, and what was the version of the output it produced. And you know what parameters were passed to it. And so we're really building that lineage graph at the run level, which means that we know exactly everything that has changed between a run that has failed and a run that has that was successful, right? So when something goes wrong, you can look at everything that has changed between the last time it was successful and the first time it failed. And this generic model applies to batch processing, stream processing, and something that, you know, you would not necessarily call a job, but you kind of need a name for those generic entities of things that process things and data that stays. And so we have some generalization of, you know, a data set then can be a DB table, maybe it's a table in your data warehouse, or it's a set of files in your distributed file system like S3, or it could be a topic in Kafka as a stream. And so you have, say, you have the generic model, and then you have some specialization so that we can collect metadata that is specific about certain type of data set and certain type of jobs, because we may have more detailed metadata. In particular, for example, if you're using something like Iceberg or Delta Lake, you want to capture the actual version of the data. Since those have version stores, that way you know exactly what version of a data set was consumed by that job at that time when that run runs. And so you can, in that sense, you can go look at the data as it was when this job ran, because we captured the version in the metadata. So that's for the model. And the design benefits being, you know all the versions of the job, how they evolved. Maybe they have more inputs and outputs, the code change of the job, and that resulted in updating the schema of the output. And so this is kind of really important in versioning everything and keeping track of what has changed, and not just what the current state of things. Because when something breaks, you want to know if, you know, you're investigating and something looks fishy, you want to know if it was always the case or if it's changed recently and that's correlated with the problem. And other things that are very useful, if you know exactly the state of the system as of before it failed, you can roll back to that state. In particular, if you're using something like Iceberg or Delta Lake, you can roll back the data set to the version before the bad job ran and created bad data. So how metadata is collected, it's very simple, push-based system. The idea is you can start from the scheduler. You know, so I'll be using Airflow as an example because this is the most popular open source scheduler out there. But you could do the same thing with Luigi or Uzi or other schedulers you might be using. And this is an open source project with an open API. So if you have your own custom scheduler, you can make your own integration as well. And basically, whenever the job runs, we add an integration to the scheduler, and it's going to call the API to say, this particular job has started with those parameters, this version of the code, and reading those inputs. And when it's finished, it's going to send another event to say the job is complete, or if it's failed, it's going to send call this API to say the job has failed. And this is a simple REST API, and the goal is to really define a standard in how we collect metadata and lineage information at runtime to instrument our job and achieve observability. And so there's simple REST API. You know, you would integrate your ETL, your batch, your stream, dashboard, and Marquez as this modular framework when there's this core model, when it stores the data, and then basically it's pluggable, right? The idea is to be modular, and you have the core representation of the data that is collected, and then we can add multiple features around it based on that, and to make it a little bit loosely coupled set of features so that it's easier to evolve over time, and to build, you know, optional extension to it. And so to go a little bit deeper in the internal layers, you have the core database and the metadata API on top of it. As part of this API, there are two major parts. One is the lineage collection, which is when a job starts and when a job ends, and collecting metadata and lineage information. And the second is the core API, which is how do I look at the job that exists? What are the inputs? What the output is kind of exploring that metadata. And on the client side, similarly, you have the integrations, which is how do we collect data? And you have the Marquez UI that lets you look at the current lineage graph. And to give you a little bit of context of what we're doing at Datakin is in Marquez, you can have a listener to get notified of all this data as it comes in. And what we do is we build a graph representation of it, and we build a bunch of tooling to help with this lineage analysis, like troubleshooting, understanding dependencies, who depends on what, understanding everything that has changed. How do I build a diff of the entire environment when something breaks or something becomes slower or the data becomes bad, and understand everything that has changed and correlate it with the problem I'm seeing. And the other aspects are you could look also at correlated failures, like maybe someone updated the version of Spark, and now all the jobs are failing between the previous version and the new version, right? And you can start doing this kind of analysis by extending the model, right? So you have the lineage collection aspect, but then you can leverage this data to do other things around the core of the project. Other things people might be doing, like typical application, are governance, compliance. You can think about GDPR or CCPA and understanding where your user private data is going, and is it being consumed by the right system or not, or where do I need to go delete data if I have a request for data deletion. And so, those are examples of other things you can build around this core Marquez module. So to go a bit in the details, this is an example of how you collect metadata, so the actual payload of the REST call. The first step is, okay, this is the source it's coming from. So this is kind of your database. It could be your Redshift, your Vertica, your Snowflake, your Dremio, or you S3 bucket when you store Delta Lake, or Iceberg data. Or it could be a Kafka broker that contains Kafka topics. So first is the source. Then you have the data set. The data set is an actual data set. So in a warehouse, it's a table. In Kafka, it's a topic. It could be a folder in S3. And you have and the last element is the job, right? And the job is the thing that consumes data sets. It has inputs and outputs. It has current version. So capturing, if the job is in GitHub, collecting the GitHub URL with the Git shot to know the current version of the job that's running. And all those things are version, right? And so what we do, we have this notion of namespace that lets us have unique names for data sets and jobs, and that's how you refer to things, right? The job is consuming this data set, which has a unique name within that namespace, and that refers to this data source as being the container for it. And so when something changes, right, you may have the V1 of the job, and it's consuming one data set, and for now it's not producing any data, and then you push the V2, and now it's updating its output, and the graph shape changes, right? So it could be, another example, if you update your job and now it's reading from an extra table, or now you update your job and the schema of the output has changed. So all those things would be version, and you'll be able to see what was the schema before and after. And so I'll take the example of Airflow to make it a little more concrete. So, in Airflow, you will have multiple DAGs. Sometimes, so the DAG is the notion of job in Airflow, and the DAG is made of tasks. So in the case of the Marquez integration, each task will be integrated in Marquez and will capture when it starts, when it ends. And you would argue that in Airflow, you have this notion of graph already, except it's only within the DAG, and it's not really showing you any data dependency, right? So you see how tasks depend on each other, but really the underlying reason that a task depends on another task is because a task is consuming the output of the previous task, right? So you have an underlying data dependency that will become visible in Marquez, and if your DAG definition is not consistent with it, it will become obvious in the Marquez UI. So we also track inter-DAG dependencies. Some organizations like to have multiple Airflow instances to make people more independent. So it's going to all stitch all that together to make one graph of all the dependencies. And the way it does it, there's a built-in SQL parser for when it's SQL to extract the lineage from that. It connects the current version of the DAG as defined by the Git shaft, for example, which is the most common as well, and extract metadata like parameters and all that. And so you add the Marquez integration to your Airflow, and now it's going to call the Marquez REST API to create those notions and track the lineage as the jobs are running. So every time a job starts, it's going to call. Every time a job is successful or failed, it's going to call the Marquez API. And so there are two ways to integrate. So the simple way, if you're just trying it out in your DAG, is to, instead of importing the Airflow DAG class, if you're familiar with Airflow, is to import the Marquez Airflow DAG, which is just Marquez extending the DAG class to add the instrumentation to it. And the other way, if you want to globally integrate that in your Airflow, in Python, you can substitute and import and say that whenever people import the Airflow DAG, import the Marquez DAG instead, and like suddenly everything is instrumented. And then Marquez has this notion of extractor, which is a mechanism depending on what operator you're using to extract the lineage information, because this is operator specific. And so, over time, there'll be more and more operator integration, we call extractors, that extract the metadata from the operator and collect the lineage information. And so some of the, depending on the operator, we can extract what the data source the data is coming from, what table is being written to, what table is it reading from, and so on. Right, and those things, based on the namespace, create unique identifier for jobs and how we collect the information from run over run, how things have evolved. And so I mentioned it, if you have two different DAGs in Airflow, then the fact that one DAG is producing some data and another DAG is consuming it is going to connect those DAGs in Marquez, and you're going to have visibility about everything that depends on each other. And so I just wanted to give some quick context about Datakin. So, Marquez has the integration and the API, and so we contribute to Marquez, obviously adding more integration and making this, just like you have open tracing, open telemetry as a standard for tracing independently of a backend, you can see Marquez as that for data lineage and metadata. And then Datakin is just leveraging that data, enabling better analysis. So Marquez standardizing metadata collection, runs, parameters, versions, inputs, outputs, and Datakin enables better understanding of operational dependencies, impact analysis, what is going to be impacted by this change, troubleshooting, how do I know everything that has changed since the last time it worked, right? How do I correlate all the changes with the failures and get really quickly to the bottom of the problem? And so now a quick pass at the community. Marquez is hosted on GitHub. You can see the Marquez project on GitHub. It has joined the LFAI Foundation. And with the obvious goal, if you want to define a standard for metadata collection, you need to be a neutral, not controlled by any company, entity, project, right? So the goal is really, as a community, to grow adoption, to show that the goal is to make a shared standard. And it's the kind of thing that the more people are using it and the more it's valuable to everyone. And have a clear decision mechanism, public decision mechanism, clear mechanism to become a maintainer, and have clear code of conduct in the project. So the LFAI, if you're not familiar, it's a sub-foundation of the Linux Foundation. It's a sister foundation of the CNCF. The CNCF is being around Kubernetes and cloud and all that. And the LFAI is more about machine learning and data. And it's a growing foundation with more and more projects joining it. So you can join the project. We have six sub-repos for the different components, the core Marquez, the UI, the integrations. There are a number of contributors already. It was started at WeWork, but with contributor originally collaborating with people at Stitch Fix and a few other companies. And it's a growing project now as part of the LFAI Foundation. So thank you. And now I think I'm right on time for taking a few questions.
Yes, or indeed. Can you hear me, Julien?
Yep.
Perfect. Just making sure. Yes, excellent. Thank you for that. Let's go. We've got one question queued up right here from Sentil. So Sentil, I'm about to add you. Let's see if this works. And meanwhile, Julien, Flavian posted a question just inside the session announcements tab. Looks like there's another question there as well. So maybe take a look at that, and we'll see if Sentil is able to join or not.
Yeah. So Flavian, thank you for the question. Yes, there is definitely a vision of Marquez working well with Amundsen, and you'll see that Marquez and Amundsen may become more closely integrated in the future. One way to see it is Amundsen is more the data discovery path, and usually it requires that you push lineage information into it. So the way we see it is to have we have a listener for Datakin. You can have a listener in Marquez for Amundsen that would make it easy to push whatever lineage you collect with Marquez into Amundsen, and probably have some kind of cross-linking in between the two. So for right now, it's not being beyond the proof of concept step, but it's something we're eager to see happening. We're friends with Amundsen folks, and they do a good job. I think Marquez is more focused on the core, on how do we collect lineage, and Amundsen has a lot more on data discovery, that type of use case, and how we know all the data that exists. And so there's clearly a good partnership to have here.
Great. Okay, I'm going to try and add Kyle Hannon. Let's see if this works. Kyle just raised his hand. Here he comes.
Hey, Julien. This is pretty cool. We're actually looking at something similar internally. So I had a question for you on data versioning. How do you guys handle versioning for things like streams where you're continually getting more and more data added onto it? Do you just, I guess, yeah, how do you handle it?
So there's like the way. So like I said, we try to have a unified model of jobs and data set, right? I mean, we have a unified model like that, and so job can be batch or streaming of different sort. But the other thing we do is specialize, and to have also, depending on the type of job, you have different metadata. Because obviously for batch, you capture those dependencies like would want to capture partition level and dependency at this level. And at the streaming level, it's very different. So you have this notion of run, and then when it's a batch process, the run is every time the job starts and ends, that's a run. For a streaming job, a streaming job doesn't actually run continuously, right? So it will run from a point on until you stop it. And then you may stop it to update it, right? Maybe you change the code and then you redeploy it and then you start it again. Yep. And so the notion of run then matches those things, right? So you will have a notion of run. And then one thing we do is whenever, a run stops, and it's kind of like it creates a version of the data set. So for streaming, we're not going to keep track. The goal is also the metadata as a reasonable volume, right? So we can keep track of the job has changed, and so at least capture that information. Other information that we capture is the schema has changed. So if you're using something like Agro schema registry, schema registry in general, and the fact that the schema has changed, and so the schema registry will keep track of versions of the schema and like incremental values to it. And so we can store that in the metadata. The streaming aspect of Marquez is something that is still more to develop. So this is kind of like the beginning of the thinking. if you wanted to push it, you could actually, when you start the job and you checkpoint, usually you store your state. Typically, it's a list of partitions that are in read, and then what is the offset of each of them. So you could imagine a way of storing just that information that captures the exact version when you start reading, when you start the job, and save that in the version that is connected to the one that just ended, if you wanted to save that. So this is not something that exists in Marquez today, but you could imagine adding this metadata. The goal is you have the core model, and then it's extensible. So per type of data set, per type of job, you can have more metadata that's related to that in particular, and that will make sense and help to capture that more precisely.
Okay, cool. No, I think that makes sense. I mean, it's a complicated topic, so we don't have a good answer for it either. I was hoping you.
Yeah, but I think one of the goals of Marquez is to have a precise modeling of how it actually works and when the actual version are, so that you capture the state of your system. And, you know, like the holy grail, for example, on the batch side, is when a job has failed, or actually the worst case is the job has not failed, but it produced wrong data. And a bunch of other jobs have been triggered from that, and the process didn't produce more wrong data, is knowing exactly what needs to be rerun and how do we roll back to the previous state. So if you capture the entire state and you have things like what was the version of the data set before it ran, and you can roll back everything to what it was before, and you know exactly everything that needs to be rerun. So it's kind of the same idea. And so we spend less time on streaming for now because, but this is very welcome, you know, and this is, we want to grow this community. If people want to focus on the streaming area, they're very welcome to join the conversation, you know, provide pushing this area forward.
Great, so I'm gonna jump in with that. We're out of time, so thanks to everybody. Thank you, Julien, really appreciate it. Great questions, and take the conversation to Slack. So I just put it into the chat here. Jump over there, Julien will be there, and of course that community will continue to exist even after the event. So thanks all.
Thank you very much. I had a great time. Have a good day.